Hello everyone. In this video, you will learn how to find relative maxima and minima of a function using first derivative test and second derivative test. First derivative test. Suppose that f is continuous at a critical point x equal to c. You need to find f prime for x less than c and x greater than c. So for x less than c, if you have positive and then greater than c, you have negative, it means that for positive, f is increasing. For negative f prime value, it means that f is decreasing. So you will have increase then decrease. It means that you have a max point at x equal to c. For x less than c, you have negative f prime value. It means that f is decreasing. And if you get positive f prime value for x greater than c, it means that f is increasing. So you will have decrease and then increase. It means that x equal to c is a minimum point. If you have for x less than c positive, for x greater than c positive, or you have for x less than c negative, x greater than c negative, or in other words, no changes in sign of f prime. It means that no relative extremum at x equal to c. Second derivative test. Suppose that f is twice differentiable at a critical point c. This time, you substitute c into x of the second derivative. If you get positive, then you get a relative minimum at x equal to c. Because if positive, it means that it is concave up. So this is a minimum point. If you have negative, means that it is concave down. So you get a maximum point. And if you have equal to 0 for the second derivative, inconclusive, either maximum, minimum, or neither at x equal to c. Example A. Locate the relative extrema if fx is equal to x squared minus 4x plus 3. First step, find the critical point. F prime x equal to 2x minus 4 equal to 0. So you will have x equal to 4 over 2 equal to 2. So this is your critical point. Now we use first derivative test. This is your line number. You only have one critical point, 2. So this is your f prime. This is your f. Check for a number less than 2, for example 0. F prime, substitute into x, you get 0 minus 4. So this is negative. It means that f is decreasing. And then choose a number greater than 2. For example, 3. Substitute into f prime. 2 times 3, 6. 6 minus 4 is equal to positive 2. You have a positive number. It means that f is increasing. So according to the first derivative test, x equal to 2 is a relative minimum point. Because you have something like this, going down and up. The second derivative test. Find the second derivative, f double prime x. So if you differentiate this, you get equal to 2. And this one always positive. So f double prime, you substitute 2, the critical number, this number, this is equal to 2. Actually, whatever number you put into here, you will always get a positive 2. And this is greater than 0. It means that you have a positive number. Therefore, you can say that x equal to 2 is a relative minimum point. Two different tests. This one, first derivative test. And this one, second derivative test. Second example, fx is equal to x cubed minus 3x plus 2. So first find the critical point. Find the first derivative. This one equal to 3x squared minus 3 equal to 0. So if you solve this, x squared equal to 3 over 3 equal to 1. So x equal to plus minus 1. Now you have two critical points, minus 1 and 1. So using the first derivative test, you have 2. One is minus 1, the other one is 1. F prime, and this is your f. Choose a number that is less than negative 1, for example, negative 2. Substitute into f prime. Negative 2 square, you get 4. 4 times 3, 12. 12 minus 3, you get a positive number. Therefore, f is increasing when x is less than minus 1. Choose a number between minus 1 and 1. For example, 0. Substitute into f prime. 3 times 0 is 0 minus 3. So you get a negative number. So f is decreasing. Choose a number that is greater than 1. For example, 2. Substitute into f prime. 3 times 2 square is 12. 12 minus 3 is a positive number. So in here, f is increasing. So you have x minus 1 is a, you go up and down. So this is max. This one you go down, decreasing and increasing. So this is your mean point. You can confirm this result using second derivative test. Find the second derivative of this one, 6x. So you find the value is minus 1. When you substitute into the f double prime, you get a negative number. This one is equal to minus 6, less than 0. Less than 0, according to this one, it is a maximum. And then, for this one, you substitute 1 into the second derivative, you get positive 6. This one is greater than 0. Greater than 0, relative mean. So this is a minimum point. Minimum and maximum. Example C. Find the first derivative. So f prime x is equal to u per v. So this is quotient rule. V u prime minus u v prime over v square. So this one, v is x plus 2, u prime is 1, minus u, x minus 1, v prime is 1. This one, 1. Divide by x plus 2 square. So this one is equal to x minus x0, 2 minus minus 1 is 3. 3 over x plus 2 square. You cannot find a value x so that f prime x equal to 0. But the critical point is when f prime does not exist. So x plus 2 equal to 0, x equal to minus 2. Now we want to use the first derivative test to check for maximum or minimum. We read again the first derivative test. Suppose that f is continuous at a critical point x equal to c. Our critical point is x equal to minus 2. If we substitute minus 2 here, the function does not exist. It means that f is not continuous at x equal to minus 2. Hence, no relative extremum exists.